Hello, everyone. My name is Anup Kapoor, and I'm joining you from Vancouver, Canada. Welcome to the webinar for Auto Scaling, a service that lets you automatically add and remove capacity so that you get the highest performance and pay for only what you need. I'm here with a few of my colleagues who will help me moderate the chat to answer questions through the webinar. But to begin with, let's take a look at different ways you can scale your resources in AWS. We have three different ways. EC2 Auto Scaling is for scaling EC2 instances. Application Auto Scaling is for scaling resources beyond EC2. And AWS Auto Scaling is for scaling multiple resources at the same time. Let's take a look at each one of them one at a time. So first, EC2 Auto Scaling. So there are three different reasons why you'd use EC2 Auto Scaling. The first is if you want to maintain a fleet of EC2 instances that is highly available and resilient. This is called fleet management. The second is if you would like to plan your EC2 capacity at preset times. This is called schedule scaling. The third is if you want to automatically add and remove EC2 instances based on load or traffic. This is called dynamic scaling. So now we will look at each one of them in detail. So what is fleet management? So suppose you have a website hosted on 3 instances and one of the instances goes unhealthy. So this is going to affect the availability of your website. You can detect this either through the Elastic Load Balancer health checks or EC2 health checks. If such a situation occurs, you may have to manually replace the unhealthy EC2 instance with a new one. But if you put these 3 instances in an auto-scaling group, as soon as one of the instances fails the health check, auto-scaling will automatically replace the instance with a new one. And if your EC2 instance or the instances are behind an Elastic Load Balancer, it will also register the new EC2 instance with that load balancer. Not only that, as you may know that AWS resources such as EC2 instances are housed in high available data centers. And to provide additional scalability and reliability, these data centers are in different physical locations. Regions are large and widely dispersed geographic locations. Each region contains multiple distinct locations called availability zones that are engineered to be isolated from failures in other availability zones. So auto-scaling enables you to take advantage of the safety and reliability of geographic redundancy by balancing your EC2 instances across multiple availability zones within a region. If one availability zone were to become unhealthy or unavailable, auto-scaling launches new instances in an unaffected availability zone. And when the unhealthy availability zone returns to a healthy state, auto-scaling automatically redistributes the instances evenly across all the designated availability zones. So that's fleet management. So let's take another example. You have an application that lets users book meeting rooms. You know that this application is most heavily used during the office hours and then minimally used during evenings and weekends. You want the capacity to be high during office hours when the application is being heavily used and low during evenings and weekends to save money. You can do this by setting up capacity on a schedule using schedule scaling. We'll take a look at this in action during the demo. Now, while schedule scaling adjusts your capacity on a schedule, you may not always know your load pattern in advance. Take the example of a software bug tracking system. It may see periods of high activity when a bug is discovered and support cases are being logged. In this case, you can't use schedule scaling to manage your capacity. You want your EC2 capacity to dynamically change based on the load. So dynamic scaling precisely does this. You can set the criteria for continuously adding or removing capacity by either setting up step scaling policies or target tracking scaling policies. You need 2 things for this. One is the scalable CloudWatch metric, such as CPU utilization or network in or network out. And then you define a scaling threshold to add or remove capacity when those thresholds are breached. With step scaling policies, the first step is to create CloudWatch alarms for the metric you want to scale on. Then you specify thresholds for which you can specify several different responses. So let's say, for example, you want to scale on CPU utilization. You can tell auto scaling that when the CPU utilization is between 50% and 60%, you want to add 2 more instances. If CPU utilization is between 60% and 70%, add 4 more instances. So you can define these steps for capacity that you may want to add on scale out or remove during scaling. Target tracking, which we introduced about a year ago, on the other hand, offers a set it and forget it experience, which works just like a thermostat in your home or a cruise control in your car. You don't have to create any CloudWatch alarms. Target tracking will do all that for you. All you do is select a metric that you want to scale on, such as CPU utilization, and set the target value. Auto scaling does the rest to add or remove capacity to keep your metric as close as possible to your specified value. Now, there are other advantages of target tracking as well. So target tracking is self-optimizing, and what that means is that there's an algorithm that learns how the metric has been changing over time. Using this, it ensures that over and under scaling is minimized and oscillations are also minimized. You also get the fastest scaling response since we continuously calculate how much the capacity should be added or reduced based on how far away the actual metric value is from the target value. Let's take a quick example of how target tracking would work in a scale-out situation. You have EC2 instances and an auto-scaling group behind a load balancer. Your target CPU utilization is 50%, and everything looks great with 10 instances in the ASG to serve the current traffic that's coming. Now, the load balancer starts to get more traffic. This in turn sends more traffic to the current EC2 instances, which in turn makes the CPU utilization higher and goes up to, say, 75%. Target tracking does the calculation for how many instances would need to be added to bring the CPU utilization back to 50%. In this case, it turns out another 5 instances would be required. Auto scaling spins up another 5 instances. The CPU utilization returns to 50% and everything looks great again. The exact same concept applies in the scale down policy as well. Now, one question you may have is, what target should I set? So if you're scaling on the application load balancer request count per target metric, which is one of the popular metrics to scale on, you need to understand how many requests can each of your instances handle. Usually this setting is on your IIS or Apache or any web server technology that specifies how many concurrent connections a web server can handle. Your target can be no more than what that number is. If you're scaling on average CPU utilization, which is another popular metric used for scaling, you'll need some empirical evidence. And that empirical evidence can be as where you start seeing performance impact such as latency once CPU utilization goes above a certain threshold. So you want to keep your target below that. Now, once you've determined that, you should also answer a few additional questions. How quickly do your EC2 instances launch before they start receiving traffic? If your instances take a while before they can start receiving traffic, which means they might have a little bit longer bootstrapping times, registering behind a load balancer, then you want enough of a buffer to be able to service the traffic while the additional instances are being added. The second question you might want to ask is, how fast does the traffic ramp? If you expect fast traffic ramp-ups, once again, you need enough of a buffer to handle the spikes and serve the additional traffic while the new instances are spinning up. If you don't expect fast ramp-ups, you can afford to keep less of a buffer. Now let's take a look at EC2 auto scaling in action. So from the EC2 console, we can get to the auto scaling console. And in order for us to create a new auto scaling group, we need to start with either a launch configuration or a launch template. So either of these is basically a collection of the information that is required to spin up new instances. So launch configurations is what was supported traditionally with auto scaling groups, and launch templates were introduced last year at reInvent, which are similar to launch configuration, but they have some more advancements, such as they are versioned, they support some of the new EC2 features, such as T2 Unlimited. If you want to tag your EBS volumes, you can do so. If you want to attach elastic graphics, you can do that as well. So for this purpose, I'm going to start with a launch configuration. So I'm going to go ahead and create a new launch configuration. So this should be very similar and familiar to if you've launched an EC2 instance from the launch instance wizard. So the steps are very similar. I'm going to first select the Amazon Linux. In this case, I want to select the Amazon Linux AMI. Once done, I'm going to go ahead and select the instance type. I'm going to select C4.large. Then I'm going to give the launch configuration a name. And here I can choose if I want to request bot instances. I can go ahead and select that option. If I want to enable detailed monitoring for my EC2 instances that are launched in this auto scaling group, I can go ahead and do that. Once done, I go to the next step. I can modify my root volume. If I need to add any other EBS volumes, I can go ahead and make those modifications. Select the security group. I'm just going to go ahead and select the default and the final step, review. And I'm going to go ahead and create the launch configuration. Now that the launch configuration has been created, I get to the create auto scaling group step. So here I'm going to give my auto scaling group a name. And I'm going to start with 3 instances. And I'm going to continue to be in my default VPC. And I want to have high availability for my application. So I'm going to spread this auto scaling group across all 3 availability zones in the Ohio region. So I'm going to select all 3 default subnets. If I want to register my instances with an Elastic Load Balancer, I can do that as well. I can do it with a classic load balancer. If I have my target groups with my application load balancer or network load balancer, I can do that as well. So this is where I can configure my dynamic scaling. So I'm going to go ahead and do that. I'm going to say that I want to scale my instances between 3 and say 10 instances. And my starting point is 3 instances as I selected in the last step. And I'm going to give this is what the target tracking scaling policy is. So I'm going to give this target tracking policy a name. And I'm going to select my metric as average CPU utilization. We have some other predefined metrics as well. We also support the application load balancer request count per target, network in, network out. And if you have a custom metric that you want to scale on, you can do that as well if you're using the SDK or the CLI or the API. I'm going to say that I want to maintain the average CPU utilization at 50%. For the warm-up time, I'm just going to keep the default 300 seconds. That's how much time my instances need in order to bootstrap and come up before they can start accepting traffic. So this is all it takes to configure a target tracking scaling policy. And just for reference, I'm going to show you step scaling as well. So this is what step scaling looks like. In this case, you would have to create a new alarm. Once the alarm has been created, you can add your steps where you can define, or if it's between 40 and 50%, I want to add 2 instances. If it's between 60 and 70%, I want to add 4 instances, and so on and so forth. So you have to define that for your scale out policy, and then you also have to define that for your scale in policy. But I'm just going to stick with the target tracking scaling policy, which is going to work extremely well for me. I can add notifications, any action that happens in this auto scaling group, such as instance launches or any failures. So I can set up notifications for that. If I want to include any tags, I can add the tags here. So any new instances that are launched, they will automatically end up inheriting these tags. Next, I review and everything looks good. So I'm going to go ahead and create the auto scaling group. And here we are. So this is the auto scaling group that has now been created. And now we can see if I go to instances, so we decided to start with 3 instances, and now I can see that I have this span across 3 availability zones, and each of these instances is being spun up in each availability zone. So that's great. So the last thing I wanted to show you was scheduled actions, what we talked about. So if I want to create a scheduled action, very simple and straightforward. All I do is give the scheduled action a name, and I go ahead and select when I want this action to happen. So say if it's a one-time action, I want this to happen on June 15th at say 9 a.m. UTC. And at that point in time, I say, okay, at 9 a.m. on 6/15, I go ahead and update the min to 4 instances and my max to 12 instances and move the desired capacity up to 8 instances. And I will go ahead and create the scheduled action. So that's it. That's how easy it is to create a scheduled action as well. So now that we've seen how easy it is to set up EC2 auto scaling, next let's go ahead and take a look at application auto scaling. So application auto scaling extends the concept of auto scaling like we saw in EC2 to other services in AWS. Currently, 7 services can be auto scaled using application auto scaling. And let's look at what scaling means for each of these services. So in case of DynamoDB, which is a non-relational database service, you can scale the provisioned capacity of the tables and global secondary indexes. On the other hand, for ECS, you scale the tasks running in your services. How you scale these services will vary from one service to the other. All services support schedule scaling, just like we saw in EC2 auto scaling. And all services support either target tracking or step scaling policies. And some services, they support both. You get the same experience as EC2 for these other AWS services. You pay for only what you need and what you're using while maximizing the availability of your applications. Now next, let's take a look at how easy it is to set up auto scaling for a DynamoDB table. So let's go ahead and go to the DynamoDB console. Now when I create a new table, if I stick with the default settings, for the default settings, auto scaling is going to be automatically enabled. This is if I'm doing it through the console. So auto scaling is automatically going to be configured where we're keeping the target utilization of the provision capacity at 70%. If I don't want to use the default settings, I can go ahead and manually update the read capacity and the write capacity. So say if I want to change it to 60%, I can do so. I'll go ahead and change board to 60%, and that's it. When I go ahead and create the table, once the table is created, which will take just a couple of seconds, we can see here in the capacity that auto scaling has been configured. And as I add write data, read data, I'll be able to see that in my metrics. Anything I want to change for auto scaling, I can just do it with a few clicks and everything will be good to go. So now that we've taken a look at how easy it was to set up auto scaling for DynamoDB, let's move on to AWS Auto Scaling. So AWS Auto Scaling is a quick and convenient way of scaling multiple services at the same time. It abstracts some of the decision making from the user, making it faster to set up. It also offers visual dashboards, making it easier for users to understand and see the scaling behavior of their resources. You can define your application based on either a CloudFormation stack or based on resource tags, and use AWS Auto Scaling to scale all the resources underlying your application in concert. It is easy to set up AWS Auto Scaling in 3 simple steps. First, you select the application, which can be either based on a CloudFormation stack or on resource tags. Next, AWS Auto Scaling will scan your application for the supported scalable resources. Next, you simply configure one scaling plan for all the resources. What does a scaling plan look like? Using a scaling plan, you can select a scaling strategy, which can either be a predefined one, such as you want to optimize for availability or optimize for cost or balance between the two, or you can define your own custom strategy. You can even select a different scaling strategy for each of the resource types. So if you want to have a separate strategy for your Dynamo tables than your auto scaling groups, you can do that. Now, once you've selected the strategy and the resources to apply on it, AWS Auto Scaling is going to use target tracking to dynamically scale all resources and shows you how scaling is working for each one of them. So now let's take a look at AWS Auto Scaling in action. So AWS Auto Scaling is a top-level console, which can be found under Management Tools. So I'll go ahead and click on Get Started. So here's the option that's given to me if I want to select my application either based on a CloudFormation stack or based on tags. Now in my case, my application, I created the resources and I ended up tagging them. So that's how I'm going to end up defining my application. So for the key, I'm going to select Web App, and the value that I had defined for the resources was my web app. So once I've made the selection, I click Next. Now here I can see that AWS Auto Scaling has identified 3 scalable resources. So here I can see one auto scaling group and 2 DynamoDB tables. So now here I can see that my CPU utilization for a while it was at around 70% and then it started coming down. But I want to maintain my auto scaling group such that I optimize for availability. So optimize for availability means that it's going to set the average CPU utilization at 40%. If I choose to optimize for cost, it would set the target utilization at 70%. If I chose to balance between the two, it would set it at 50%. But like I said, in my case, I want to go ahead with optimizing for availability. And I want to do the same with my DynamoDB tables as well. Here as well, I want to go ahead and optimize for availability. So what I can see here is that my target utilization is 40%. For a while, the utilization was pretty high. Probably the requests were even getting throttled, but once the auto scaling is enabled, the provision capacity should be increased, and then all these effects of throttling that I was seeing, I would no longer be seeing those. So once I've made the selection, and I'm going to give my scaling plan a name. So once I've done this, I go to the next step. Here I can review what scaling policies will be created. Uh, Here I can see for the auto scaling groups, target utilization is going to be 40%. It's going to set the min size of the auto scaling group as 1, the maximum size of the group as 25. And I can review the details for DynamoDB as well. And that's it. I go ahead and create the scaling plan. And in just a few seconds, I will see the scaling plan created and in action. And once I get here, I can take a look at the scaling dashboard as well. So here I can see how the CPU utilization has been, what the target is, and moving forward, how well the scaling is working and how closely my actual metric is tracking to the target. So that is how we created a scaling plan using AWS Auto Scaling. I hope you'll start using auto scaling to optimize your applications for both performance and cost. Thank you so much for joining, and we will hang around for a bit in the chat room and continue to answer your questions. Thank you.